Heavy machinery is now being designed to tear into the lunar soil on a scale that dwarfs any scientific mission from the 20th century. Global superpowers and private corporations have begun a trillion-dollar competition to secure industrial territory on the moon. This scramble for territory is centered on a single, specific resource, a rare isotope called helium-3. Controlling this material would provide a level of energy security that is currently impossible using resources found on our own planet. Helium-3 is considered the ideal fuel for nuclear fusion, the same reaction that powers the sun and the stars. Its energy density is staggering. If we could capture it, just 2 space shuttles full of helium-3 would contain enough energy to power the entire United States for a full year. Beyond the raw power, this fuel offers a way to generate electricity with zero radioactive waste, bypassing the primary environmental hurdle of traditional nuclear plants. However, finding this isotope on Earth is nearly impossible. Our total global supply is measured in grams, not tons. We have the conceptual blueprints for the reactors, but the fuel remains out of reach, creating a massive incentive for whoever can find a reliable source beyond our atmosphere. To find that supply, we have to look toward the sun, which functions as a massive natural factory for helium-3. For billions of years, our sun has been violently ejecting these particles into space through high-velocity solar winds. These winds carry the isotope across millions of miles, eventually reaching the space surrounding Earth. But Earth is protected by a powerful magnetic field, a shield that deflects these solar winds away from our atmosphere. This causes the helium-3 to bounce off the magnetic lines and scatter into the vacuum, preventing it from settling on our planet. The very same magnetic protection that makes Earth habitable also prevents us from accessing the solar system's most efficient fuel. The moon has no such protection. It sits in a total vacuum, completely exposed to the environment of deep space. Without a magnetic shield, the lunar surface has taken the full, direct impact of the solar wind for eons. As these solar particles hit the ground, the loose lunar dirt acts as a physical trap, absorbing the helium-3 and holding it in place. This left millions of tons of the isotope embedded in the lunar dust, a massive energy reserve waiting beneath the surface. Billions of years of bombardment have turned this lifeless rock into the richest known deposit of helium-3 in the solar system. This astrophysical reality is what changed the logic of space travel. The moon is no longer being viewed through the lens of exploration, but as a site for extraction. We can already see nations mapping out specific territorial boundaries near the lunar South Pole, targeting the craters where the highest concentrations of the fuel are expected to be found. Engineers are already testing robotic harvesters designed to sift through this dirt, heating it to release the gas for transport back to Earth. We are watching the first steps of a physical and legal land grab on another world. The entity that successfully secures these deposits will likely dictate the price and availability of clean energy for the next century. The goal has shifted from making brief visits to the surface to establishing permanent, industrialized facilities capable of large-scale fuel production. This is how the first lunar mining empires will begin. As our energy infrastructure moves beyond the limits of Earth, the moon is becoming the most valuable piece of real estate in reach. Subscribe to follow the future of humanity in space.